Kesavanandan, final year mechanical engineering student of BTech at Maharaja Agrasen Institute of Technology, and today I am going to explain my final year major project, that is vapor adsorption refrigeration system. Before getting into the major components of my project, I will explain what are the aims of my project. My aims in the major project are design of VDRS, fabrication and development of VDRS, performance evaluation and improving energy efficiency. Now I will explain why we have used vapor adsorption refrigeration system. See, there are certain points which are necessary that why we have used vapor adsorption refrigeration system. In this we have used HFC 134A. It is environment friendly because it has very less GWP and ODP. If we see in the moving parts of our project, there are very few moving parts, and other things which make it very beneficial are it can be used in the remote areas and it has fewer moving parts. Also, it uses a low grade heat energy, that is, it can be run on solar heat, wastewater heat or the engine exhaust. The major applications in the vapor adsorption system are: it can be used to cool the electronic components, it can be used in remote areas for medicine cooling, and in a small scale it can be also used for cooling purposes. Now I will explain the principle of vapor adsorption refrigeration system. In this we have two major processes which are taking place in the thermal compressor. Number one is adsorption and number second is desorption of the refrigerant vapor. In the adsorption, the refrigerant HFC 134A comes and sticks on the surface of adsorbent, that is activated carbon. This is adsorption. And when the cooled water is supplied, then desorption takes place and the refrigerant vapor leaves the surface of the activated carbon. In this way these processes are taking place, and this creates a pressure difference which is the power source for the operation of the compressor.
Everyone, I am Muhammad Kumar and I am going to explain the major components of our VDRS system, that is vapor adsorption refrigeration system. Here there are 4 filter dryer which is mounted on the thermal compressors, and 4 pressure gauges which measure the pressures of the refrigerant, and filter dryer is control the moistures of the present in the refrigerant, and there are 8 solenoid valves are present on the line of evaporator and condenser line, that is evaporator line, that is the condenser line, that is 8 solenoid valves which control the flow of refrigerant. And then which for controlling of solenoid valve there are 8 switches which are mounted on this panel. The right hand side is evaporator and there is left hand side is condenser. And going forward, here are this is our cold storage tank and this is our hot storage tank, and for the pump, the cold storage tank pump is located inside the tank, and for hot storage tank the pump is located on that side. And let's move the forward. There are 4 thermal compressor, 1, 2, 3 and 4. There are total 4 valve are mounted on the one compressor, 2 for hot water supply and 2 for cold water supply. The right hand side is for hot water supply and left hand side is for cold water supply. Here the water from the hot storage tank are come from this valve and goes to this pump, and then after the pump this water goes to the rotameter, and then after this pipe or rotameter, this is going to this CPVC pipe, and here are 4 valves are connected, 1, 2, 3 and 4 for each thermal compressor. And here come to the thermal compressor 1, this pipe here the hot water in and cold and then hot water out. Here after this valve, this water goes to this hot storage tank. And similarly for thermal compressor 2, here the hot water in and hot water out is this hot storage tank. And for cold storage, here the cold storage tank, from cold storage tank, the water comes to this rotameter, and after this goes to this CPVC pipe, and here from 4 valves are connected, 1, 2, 3 and 4 for each thermal compressor. Here from left hand side, here there is water inlet to this thermal compressor 2, and from here the water outlet from thermal compressor 2 to this storage tank. The pump inside this tank pressurize the water and continues the flow in the thermal compressor. Here one more thing, this white pipe indicates for the supply of hot water, and this transparent pipe indicates the flow of cold water in the thermal compressor. After this we have one more pump are located, that is vacuum pump. It is for vacuum of the system, whole system testing or gas charging, and two valves are also mounted for the drainage of water. Yes, and after let's move forward. Here are the evaporating plate. This is 10 by 10 into 5 mm.
1.
Here is the capillary tube which are mounted on the evaporating plate, and here is the main condenser unit for our test rig, and here the compressor, condenser and capillary tube is used for the cooling the water in the cold storage tank, and it is a separate part. It is for mainly cooling the cold water in cold storage tank. After that we move on the piping of this piping of our test rig. That is from here a filter dryer. It's come from the evaporator line, and it is the condenser line, it is the evaporator line. And after the condenser, this goes to this condenser and moving to this and evaporating plate, and after this goes to this solenoid valve and the thermal compressor, and from thermal compressor this goes to this, and after that it moves to this condenser pipe.
1.
Moving on forward, we come to our display section. Here are the voltage and ampere meter which shows the voltage and current in our system. This is the fuse for safety purpose, and this is the on off switch for main system. This switch is for compressor that is installed in the below of this, and this is for this switch is for heater, and this shows the present and set value. The set value of hot storage tank, that is the heater present in the hot storage tank, is 74.8 and present value 32.1, and this is for cold water storage tank. Here the temperature shows 29.3 degrees Celsius, and here the 12 thermocouples are installed in our system: T1, T2, T3, T4, T5, T6 and so on. And moving forward, here are the 12 thermocouples are located. Here are the T1 which shows the thermocouple of the hot water section which going to the thermal compressor 1, and T3 shows the water which are going to the thermal compressor, the outlet of the thermal compressor 1, and here so on T4 and T5 and T6 and T7 and T7, T8, T9 and T10 shows the refrigerant temperature which are going inside the thermal compressor 1, and 1, 2, 3 and 4, and moving forward, T11 and T12. T11 is the temperature before the evaporating plate, and the temperature T12 shows the temperature of the condenser line, which going the refrigerant going to the condenser. And then moving forward, there are the two service ports are also located, which is used for the charging of gases R134A. Here are the refrigerant R134A, and this is the pressure gauge, and this is the watch glass to charging of R134A gas in our district.
Now I am going to demonstrate how the vapor adsorption refrigeration system is going to work. For that, here we have the evaporator valve switch for the thermal compressor 1. Now I am going to switch this on. By switching this on, the refrigerant will come and enter into the thermal compressor 1. And after that, I will regulate the valve of the hot water pump. I have to set this value between 0.5 to 1 LPM. I am switching this on. Okay. And after that, here we have thermal compressor 1. We have to regulate this valve in on condition so that hot water will come and enter this thermal compressor. This valve has on, and this shows the outlet of the thermal compressor 1, and this shows the inlet of the thermal compressor 1. Now the hot water pump has to be switched on so that the hot water pump will work and hot water will enter into the thermal compressor 1. See, here you can see the needle, it is between 0.5 and 1. I will leave this needle in this position. To stabilize the temperature readings, we have to operate our model for 15 to 20 minutes so that a stable reading could be achieved.
Now 15 minutes passed, our required temperatures, that is the temperatures of thermocouple 7, that is T7 34.6 are achieved, and we now remove the refrigerant from thermal compressor 1 to the thermal compressor 2. For this, we close the evaporator line, and evaporator line is the solenoid valve 1, and open the condenser solenoid valve for passing the refrigerant to the next thermal compressor 2. For this, we open thermal compressor 2 evaporator line, and then we close our valve that is a supply of hot water to thermal compressor 1, and open the hot water supply to the thermal compressor 2, that is this and this, and closing of this and this. And to remove the refrigerant from thermal compressor 1, we now open our cold water supply to the thermal compressor 1. And for the cold water pump, we have a switch on display. Open this, and we control the flow of flow of water to 0.5 to 1, and we now take 15 to 20 minutes to set our temperature to that is T8, which now the temperature decreases, T7 temperature decreases and T8 temperature should be increased. For this, we wait for at least 20 minutes. After 20 minutes of running, our required temperature, that is the T7 temperature, is decreases and T8 temperature is increases. That is the T8 temperature is the temperature of the thermal compressor 1 refrigerant which is enter, and T7 temperature is thermal compressor first that refrigerant and to close our system we firstly we off our hot water pump and cold water pump and then the condenser line and the evaporator line and close all the valve of a water supply. And to collect our data we have a software that is a Prolog software which is installed in our system, and we first then off our heater and compressor, then we move forward and we have a data cable which we install in our CPU. And we have to log in first and here this is the configuration device channel configuration, that is this is T1 temperature. We change the name of the thermocouples T1, T2, T3, T4, T10, T11 and T12. 12 thermocouples are which are mounted on our setups, that is we update a remark, that is thermocouple. Also set our panel update and then we go online summary, online data display, that is the T1, T2 and T3. These are the P pressure, PV visible pressure, and T2. The 4 pressure gauges are mounted. That is the online graph, which we want any graph between any two temperature. Here we get an analysis report, that is analysis report. We want any data log report, just like that is today is 10th of 11th March, timing is 12 PM and today is bit 11. Then we want our data of temperature, then we search record. Here we get 102 data which we run. Today this is a PVT1, that is a thermocouple 1 temperature, thermocouple 2, thermocouple 3, 4, 5, 6 and so on. That is from thermocouple 12. This is the PVCH1 is no, that is open means there is no thermocouples are mounted, only 12 thermocouples are mounted here. This, and to save our data we go to preview and then we save as the name of reading of vapor adsorption refrigeration. Here we get reading in our download section, reading here, and here this shows the minimum temperature of T1 and maximum temperature of T1, that is thermocouple 1, and average temperature 54.5 4C. This is so basically 12 thermocouples are included. And so from 1:48 1 p.m. the data are these data, and we plot this in graph. We want to plot graph that is here between I1 T1 and T2 graph. Here is the graph between T1 and T7. The various colors shows the different thermocouples which are shown in this graph between the T6 and T7 graph. Okay.
So this was our demonstration on vapor adsorption refrigeration system. Now the power supply has been switched off and the system is also switched off. The readings have been taken using the Prolog software and they were noted down. And using the EES software, we have done the thermodynamic analysis of the vapor adsorption refrigeration system. And if you guys have any comment on the video.